log equations. So the first thing I like to look for whenever I'm condensing is exponents. And I see two exponents. I see the 2 and I see the 6. So I have log base 811 plus the log base 8 of 7 squared minus the log base 8 of 10 to the 6. And then I see two things that are being multiplied, that are being added, which tells me that these two are in the numerator of my fraction. So I'm just going to write it. So we have the log base 8 of 11 times 7 squared minus the log base 8 of 10 to the 6. And your last step would be to make it a fraction. This is the numerator of your fraction, and this is your denominator. So your final answer would be log base 8, 11 times 7 squared over 10 to the power 6. Who had that? All right. Now you can, because these are numbers, you could actually simplify it and figure out what is 11 times 49 and put that over, what would that be? 1 million. That'd be over 1 million. But you can also just leave it like that. Yeah, so you don't have to simplify it. You could just leave it just like that.
So we don't put like log base 8 in the variable?
No. No. That's not how you do that.
Oh, you're saying
No, it's okay. I was trying to think of when we would do that. There is a time, I guess, if it was a square root, you could put it in the numerator, but you would never put it in the numerator and the denominator. So I think you might be thinking about when we do the change base, which I think is coming up again a little later. All right, let's look at number 2. So the first thing we need to do, so we have to find our variable. This is our variable. We need to get this by itself. Okay, so what do you think I'm going to get rid of first? The 8.3, yeah. So let's subtract the 8.3 from both sides. And that's going to give us 3 times 6. And then we have our exponent, and that equals, let's go ahead and type that in our calculator. What is 52 minus 8.3? 43.7. That's okay.
She called me buddy. Oh, bro.
All right, now we have a 3 that's being multiplied. Yeah, we have to, because this has to be completely by itself before we can introduce our log. So let's go ahead and divide both sides by 3. And we'll round it to the thousands place. And that would be 14.567. Okay, so it is impossible to rewrite both sides with a common base. Like I can't rewrite 14 with a base 6. When that happens, you have to use a log. We have to use a log. I like to think of this exponent as it's in the sky. We need to bring it down to the ground. And if we can't rewrite 14 with a base 6, then we have to use either a common log or a natural log. We'll get the same answer either way. So which way do you want to go? Common log or natural log? Common log. So let's put a common log in on both sides. That's a log base 10. What that's going to do is move this to the front. So now it's no longer on the ground. Or in the sky, excuse me. So we have 8x plus 5. That's being multiplied by the log of 6. I'm going to put that in parentheses. And that equals the log of 14.567. So what you want to do now is divide both sides by the log of 6. So this would be where you would have a log top and bottom. So let's go ahead with your calculator. Again, rounding it to the thousands place. Type in log of 14.56 divided by the log of 6. And if you did natural log of 14.56 divided by the natural log of 6, you get the same answer. Who got 1.459? All right. So from there, you should be able to solve it.
Hold on.
I got one.
Yeah, I got that.
What'd you get?
No, I didn't.
Log of 14.567 divided by the log of 6. Did you get 1.95? Raise your hand if you did not get that.
Yeah, you said
459.
Oh, I'm sorry, y'all. I'm sorry. All right, so from here, you should be able to solve it. Now it's just a 2-step equation. So what's your next step?
Minus the 5.
Minus the 5. And then the last step to get rid of the 8. How would you get rid of the 8? Divide by 8. So that was kind of a hard one though. Like this one had a lot of steps in there. That's where we're trying to get to. So we're working on some harder log equations now. So that was a lot that we had to do to get to that answer. So we're going to continue solving log equations. So we're still in I think it's 5.5 or it could be 5.6. All right, so let's go ahead and copy down these two. Copy down these two. Now this first one, we'll just do one at a time. This is the first equation that involves a property. So we have to use our log properties in order to solve it because we're adding logs. So we have to condense this side down first. So because of the addition, how do we condense addition? With multiplication. So I'm going to write this as the log base 2, and then we have x times x minus 4 equals 5. Yep, we're going to distribute it. And when we distribute it, we get the log base 2 of x squared minus 4x equals 5. So now what are we going to do? We don't have a log on both sides, so we can't drop the log. What do I have to do at this point?
Equal to 0.
No.
Bay.
We got to rewrite it. You got to rewrite it in exponential form. Anytime there's just a log, if there's a log on only one side, you have to rewrite it in exponential form. So that would be 2 to the power of what? 5 equals x squared minus 4x. And what is 2 to the power of 5?
32.
32. Good.
Then we equal to 0.
And then you equal it to 0. What you mean go with the flow? What don't you know?
I said we get 2 to the power of 5.
Okay.
Let's rewrite it.
Yeah, you have to rewrite it. So this is the base. That's the exponent. So it's 2 to the power of 5 equals x squared minus 4x. All right, go ahead and factor that down. So you need two numbers that multiply to give you negative 32 and add to negative 4. Don't say it out loud. Give everybody a chance to think about what those numbers could be.
And we just solve for the x.
Yeah, we're solving for x. And we have to also, this time we will have something that's extraneous. Because at the end, we have to remember this has to be a positive and that has to be a positive. So you're a little bit ahead of me. So what would be my two numbers?
8 and negative. Wait, negative 8.
Negative 8 and positive 4.
I thought you were talking about like your x.
And then when you set them equal to 0, we get x equals 8, x equals negative 4. So let's see, if I put the 8 here and here, are these two bubbles, do they stay positive? All right, what about the negative 4? No. Okay, you cannot take the log of a negative number. You can't take the log of a negative. You cannot take the log of 0. So this one is extraneous. This is the only solution we have. That's the only one that will work. All right, go ahead and copy down question 2 if you haven't already. This one will go a lot faster. So it's two different ways we could go about doing this one. We could either move the 2, make it an exponent, or we can divide the 2. Which one you want to do? You want to move it, make it, you can use our property, or we can divide it. All right, let's divide it. So then that gives us the log base 9 of x equals 3 over 2. So again, there's only one log. So you have to rewrite it. Does everybody know where she gets the BAE from? B-A-E, base, answer, exponent. So if you rewrite it, it would be 9 to what power? 9 to the power of 3 over 2 equals x. Which, since we're getting really close to the final, let's just review how you would simplify that real quick, what that means. That's the same as saying the square root of 9 to the power of 3. That's what that's telling you to do. Which would be, I know, that's going way back to August. So after Thanksgiving, we'll start, well, soon after Thanksgiving, yeah, we're going to start getting ready for the final. The final in this class is worth 20%. This is our last test. So we would get 27 equals x. We might have a quiz, though. We might have a quiz.
Why, huh? Wait, why could you not just put that in the calculator as 9?
You could, but I was trying to teach you what it means. Because, you know, we depend a lot on a calculator in this society. And you can. But I was also, because that is my job as a teacher, trying to explain how you could do this without a calculator. I try.
That would be 3 square root, no, 3 times 2. 3 cubed.
It'll be 3 cubed, which is 27. All right, next 2. Let's go ahead and copy it down.
But the 2's right there.
Because it's the square root.
Oh, so you
It's
can't,
the
it
square
can't-
root.
No, just put it in your calculator like you said.
No, now I'm trying to actually look.
Oh, now you want to
It's
learn.
It's the square root of 9 to the power of 3.
The square root of 9 to the power, yeah, but the 2 is right there.
Yes, because it's the square root. She just put the 2 there because in the elbow of the square root.
Oh, that's where the,
The
okay,
number.
okay.
I like that, the elbow. That's cute. Yeah.
Oh, yeah, it's cute, but I don't know.
So you just take the square root of 9, which is 3.
That makes sense, all right, I got it.
All right, so we have another equation that has a property. So when you take your test next week, you will have equations that have properties. And I think the biggest mistake is doing the wrong property. So someone may look at that and say, oh, I have to multiply it. But that's not multiplication because it's subtraction. So what do we have to make? Subtraction becomes a fraction. So we're going to write this as the log base 5, and now make your fraction. X plus 1 over x equals 2. And now again, we have to rewrite it. So if we do a rewrite, it would be 5 to the power of 2 equals x plus 1 over x. And what is 5 squared? 25. So this is optional, but I always like to write it. Whenever it's a fraction on one side, I think it's easier to make a fraction on both sides. Go ahead and solve that for x. You're just cross multiplying and solving that for x. And then also we have to check for extraneous. We always check for extraneous. So we have 25x equals x plus 1. I'm going to subtract x from both sides. So 24x equals 1. Divide by 24. X is going to equal 1 over 24 or 24 over 1? 1 over 24. Positive 1 over 24. So going back to these two little eggs that we have, this one and this one. Can I keep positive 1 over 24? Yeah, so that would be my solution. Go ahead and copy down 4. We only got 2 more after this next one. We got a pretty short class because we're ahead.
Period.
So copy down number 4. Now this is not a log equation. If you don't see the word log in the equation, it's not a log. So this one does not have any extraneous roots. This is an exponential. So we don't have to worry about that red box. We don't have a red light. So what we need to do first, we have to get rid of the 5 because it's being multiplied. So we're going to divide both sides by 5. So that would be 2 equals 4 to the power of x plus 1. So now we're at this point where we could do a rewrite. So we don't need to use a log. And if you can do a rewrite, that's what I would do. Because if you use a log, then it's gonna take you a lot longer. So I can rewrite 4 with a base 2. So 2 to the what power is 4? So we're going to write this as 2 equals 2 squared times x plus 1. So we can drop the 2 and go ahead and solve that. So 2 equals 2 times x plus 1. Go ahead and solve that for x. I think I would divide the 2. Oh, you're right. It's a 1. Thank you. I do. I am. All right, so go ahead. I was going to say divide the 2, but that doesn't work now. So we're going to distribute the 2. I mean, you could still divide it, and it'd be 0.5 equals x plus 1, but who would divide the 2? I'm just curious. Would anybody divide the 2?
No, I was always told.
Or you would distribute the 2? Okay. You get the same answer, so it doesn't matter. That's the good thing about math, is that you could do it different ways and still come out on top. Subtract the 2 from both sides, so you get -1. And then divide by 2. X equals -1/2. And again, we don't have to worry about an extraneous root because this is not a log equation. All right, last 2. Go ahead and copy these down. And now we're getting into the nitty-gritty. Number 6. Number 5 is the easy one. So we'll do number 5 in a couple of minutes. But 6 is going to take a lot of time. So can I rewrite both sides with a common base? 5 and 7. So what do we have to put in on both sides? A log or a natural log. So if I put in I'm going to put in a natural log this time. If I put in a natural log on both sides, then my log properties apply. So this x gets moved to the front. So that would be the natural log of 7 equals x times the natural log of 5. Now the natural log of 5 is a number. So we're going to divide both sides by the natural log of 5.
And we always divide the side with the x, right?
Yeah, because we're trying to solve for x. So in your calculator, type in natural log of 7 divided by natural log of 5. Or you can do common log of 7 divided by the common log of 5. You get the same answer both ways. To the thousandths place. And 1.209 equals x.
Will it always be to the thousandths, or will it just tell you?
I'm gonna look at the test, but I believe, I believe it's always to the thousandths. All right, so this is our last one. This is the one that has a lot of work. So this is kind of leading up to this question. Why do you think I think this has a lot of work? Because what are we gonna have to do with that x plus 5 and x minus 4? You're gonna have to multiply it. So that means you might, if you don't know the pattern, you might have to make a box. So we're going to multiply these together. So that gives us the log base 6 of x plus 5 times x minus 4. That equals 2. Yes.
Is there a reason why you're writing it above? Like, is this kind of looks like the exponent, the x plus 5 or x minus 4? Or no?
Wait, what? This looks like an exponent?
No, the x plus 5 and x minus 4.
Oh no, I was trying to make this look like a. No, this is not an exponent. Here, you want me to move that log up? Maybe. I didn't think it looked like an exponent. Is that better?
Yes.
Okay, there we go.
Do we drop a log because it's just on log? Like, because we have 2.
No, we have to do the properties. You cannot drop it. Now, if they were on opposite sides of the equation, we could. Yeah. So go ahead and make a box. If you don't know the pattern, go ahead and multiply that x plus 5 times x minus 4. So you have to make a box. Go ahead. See what you get when you multiply that. Okay, who got that x squared plus x minus 20? Now what do we have to do? Yeah, we got to put it in exponential form. So that would be 6 to the power of 2 equals x squared plus x minus 20, which is 36. So we can subtract that 36 from both sides. And we get 0 equals x squared plus x minus 56. Go ahead and factor that down. Don't say it out loud. Factor it and solve it. Two numbers that multiply to give you negative 56 and add to 1. I do believe you have this on a question like this on the test where you have to multiply it. So you're going to have to FOIL it and then bay it. So I think that's all. This is looking familiar. So what are your two numbers that multiply to be negative 56 but add to 1? 8 and negative 7. Good. Which means our two possible answers are negative 8 and positive 7. But we have to remember, let me zoom out. This has to stay positive and this has to stay positive. So can I use both of those numbers? No. Because if I put the negative 8 in that blue egg, it's going to be a negative 3. So right there, I know this is not going to give me an answer that I can use because we cannot take the log of negative 3. What about positive 7? Will that work?
Yeah.
So it is possible that both of them don't work. So you have to check them both because you can have a log equation with no solution. And this will be your final answer. All right, we're going to pick up here tomorrow.